Hello everyone, and welcome to another conversation about various industry topics. This time we will discuss energy saving, energy management, and all the relevant matters with David Bean from the UK. And maybe I will start with a small anecdote about my guest.
Oh, right. Okay.
So,
let's hear it.
In the past, when I was working in Japan, I used to visit a lot of customers, including Europe. And I remember visiting one customer in the UK. And I thought at that time that I am speaking, let's say, decent English. But actually, David ended up translating what I say to the proper English, and I will never forget this kind of situation. So to all of the UK colleagues joining, apologies, I'm doing the best I can.
I'll just translate that, shall I?
But David, so maybe you can introduce yourself in a couple of words.
Yeah, so hi, I'm David Bean. So I'm a Business Development Group Manager for Mitsubishi Electric in the UK. Yeah, I've probably spent 30 to 35 years in automation, industrial automation. And certainly over the past 3 to 4 years, I've had a focus looking at energy and energy solutions that we can bring to market to really address the need for change that we're going to talk about this morning in our energy systems. Okay.
Yeah. We have known each other for a while.
Yes.
But I'm glad that we have chance to discuss very important topic because I think that the energy has become important at least 3 times in the last decade for different reasons. And it seems again in 2024, it is a crucial topic for many industries. So maybe let's start by defining why.
Right. Yeah. Okay. Let's start right at the beginning here. I think our energy infrastructure is definitely going through a significant change. And there are probably 3 to 4 drivers that are impacting that change. So if we start at the first of those, and probably the most critical, is as a society how we are looking to drive and produce an electric economy. So that shift to the use of electrical energy throughout many different parts of our society. And as such, if we look at the demand for electrical energy over time, it's phenomenal how that demand is growing. So if we look at now, there are some statistics. If you look to the IEA, the International Energy Agency, they can provide statistics that say currently our electrical energy consumption sits in the region of 25 trillion kilowatt hours per year. Mm. By 2050, there is a forecast that will change to in the region of 60 trillion. So over doubling over the next 25 years. So that is really where we're driving this process of creating an electric society. In that energy mix as well, obviously one of the factors that's increasing and producing that high consumption forecast is the move to EV vehicles as part of that energy mix. So that's certainly the first driver, is that we've got to look at the fact that demand for electrical energy is going to grow considerably over the next 25 years. So are we going to be able to produce against that demand? We're already seeing, certainly myself being relatively UK-centric in my thought processes and what I have experience of, we see an energy network that is under a degree of capacity issues. And I think that is probably true in other sectors of the world as well. So what are the other 3 drivers we need to look at? So they are cost. We're all aware of the issues, I think, of electrical energy costs in particular over the past couple of years. Yes, those costs have subsided a little bit to date, but what that has led to is a concern over energy cost security. How is it going to impact change over time? Is that impacting investment? Well, in the UK, we've actually undertaken some sort of studies of high energy consuming manufacturers, and I'm going to lean in on some of the statistics that we've seen from that. We've seen that probably around 50% of those manufacturers have started to say that energy price security is impacting their investment. Okay, so that's certainly a factor we have to consider, energy costs. Let's look at the other two. The one we all know about is carbon reduction and that journey to net zero. You know, that is happening. You know, we might be a little bit blasé over it, I think, in terms of actually delivering carbon savings. And again, the statistics that we have would agree with that, in that 85% of the manufacturers we surveyed have said that, that yes, they are starting that journey towards net zero and carbon neutrality. But 50% of them said, well, they haven't really, although they've started, they've not really delivered any impactful results as yet. So there's a lot to play with. So carbon reduction and net zero is the third of these four drivers that are impacting, I think, the electric economy. The fourth one and the final one is probably resilience. What do I mean by resilience? Actually, the stability of our electrical energy networks. As we introduce more and more renewables into our energy mix, it does impact the stability of the network. And there is growing concern there. As we've seen, 87% of manufacturers have started to consider energy resilience as a problem. And therefore, there is definitely a growth in addressing that through the use of microgrid technology, moving partially off main grid and generating energy yourself as a manufacturer.
There is always a question, you know, how prepared the infrastructure is for that. But I think that is a topic that we can elaborate shortly on. You know, usually whenever we discuss huge trends shaping a specific industrial topic, the answer is digitalization. Somehow, this kind of all of the technologies that are related to digitalization are usually the ones that help in solving this kind of really critical issues, as you described very nicely. So how digitalization is helping in this regard?
Yeah, well, rest assured, actually, I think digitalization is having a role to play and is actually being a significant disruptor in the energy space. And what do I actually mean by digitalization in the energy sector? I'm really talking about how we can harvest and utilize all that real-time data that is now available to us through digitalization, and actually using that data to create insight into the operation of a process. And in this case, we're talking about the operations around energy production and energy management. So we can harvest all this real-time data to actually provide insight in real time and react to changes in your energy consumption in real time as well. So it's definitely playing a role. And I think where we can see that is in how the landscape of our energy production model is changing. Mm-hmm. If you look traditionally, you know, we had, you know, large scale energy producers. Obviously, most of them were fossil fuel based, but those energy producers fed out over a transmission and distribution network to energy consumers. And so it's a one-way model where we pushed out huge amounts of energy to a consumer. That model is changing, and it's changing as a result of digitalization, and we're moving towards using a series of interconnected smart grids. What do we mean by a smart grid? Well, I think there are four, and I'll try to explain this, there are probably four main elements to a smart grid. And those are, in the first instance, the use of local renewables as part of your energy mix, interweaving that with some degree of battery storage in order to produce some resilience against the loss of those renewables, connectivity with the primary grid, and that whole energy mix is then needing to be balanced. So that's one element. The next element is obviously harvesting data to understand energy consumption And we can do that through home energy management systems if we're in the residential space and looking at a smart grid. We can look at building energy management systems in the commercial building space, and we look at factory energy management systems, obviously in the manufacturing space. So that's the second element of a smart grid, is harvesting data to understand energy consumption in real time. The third element is the load balancing across the grid, your own microgrid, and how you distribute energy between the grid, your battery storage and your renewable resources, and also your consumption of them on site. And the final one, which is the real change, is the move away from being just a consumer of electrical energy to actually being a prosumer, so producing as well as consuming. So effectively being able to trade back to the grid should you be able to at any given point in time. So those are the 4 points of a smart grid. And it's what I think over time we'll see is these smart grids become more interconnected across national infrastructure, and they will become the basis of our electrical energy network. In the UK, we have an example of one at the moment, which is, I think it's Europe's biggest smart grid, and that's called the Oxford Super Hub. It's primarily an EV charging grid, but it actually mixes battery storage at scale. So I think it's 50 megawatts of battery storage in conjunction with EV charging across the commercial network across the city for buses and taxis, as well as private car charging. And in conjunction with that, we're using as a sort of a renewable energy for heating. So we're using ground source heat pumps in the residential space. And all of that is forming effectively a local smart grid, managing energy across that grid, storing where appropriate, trading back to the main grid when there is capacity to do so.
And I'd say, because all that you described, I would completely agree. It is a solution to many problems. It's, by the way, we are sitting like 1 mile from a power plant, so
yeah, we'll have to go and see that.
Yeah, it's a proper place to have this conversation. But I have a feeling that the smart grids are adding to the complexity of companies that have to, let's say, do their main job, which is for example, we are talking about manufacturing facilities, right? So I think that we can also later discuss how we can, let's say, simplify their lives. But let's talk a little bit about this buzzword, which is net zero, right? So there is a reason why energy saving has become so important again, and that is all the regulations related to the fact that sooner or later, as the European Union, as the UK, we need to become net zero, right?
Yeah.
So what's your take on the whole idea? Yeah.
Yeah. Okay. Well, again, I'll lean back on looking at what the International Energy Agency talk about around net zero, and I think there are 4 key contributors to carbon in society. Those 4 contributors, so these are the primary contributors to carbon. The first of which, and the biggest by far, is actually our electrical energy network itself. So the generation of electrical energy is a key contributor to carbon. And obviously that's what we're doing through trying to introduce renewables into our energy mix, is reduce that carbon footprint. So carbon's the first of them. The second one is our transportation network. The third one is the manufacturing space itself. And the fourth is buildings and building management. So they're the 4 key contributors to carbon. And I think digitalization is having a role to play in all 4 of those in terms of reducing carbon and reducing carbon footprint, and in that journey towards carbon neutrality. And I think Mitsubishi Electric itself has had a role to play in all 4 of those sectors in terms of delivering solutions based upon a digitalization concept which are reducing carbon. So if we take, if you like, the primary grid as a contributor to carbon, You know, we in the UK have been involved as Mitsubishi Electric in the provision of the grid interconnectors with other parts of Europe for the bringing in green energy into the UK from places such as Norway. So we've had a role to play in those grid interconnectors. If we take the transportation sector, we've had a role to play in terms of reducing carbon in our rail transportation network, where we are primarily involved in the traction power network across the UK in providing a degree of automation so that we can provide electrical energy onto the rail network. If we look at the manufacturing space, I'll probably talk a little bit more about that later as to what we can do to help our manufacturers on their journey to net zero. Finally, I'll mention building management. You know, with the advent of Iconic Suite as being part of our scope of portfolio as Mitsubishi Electric, which in itself is obviously a visualization and data management tool. We can actually use that for managing intelligent buildings, so collecting and harvesting data from a building to ensure that it is performing optimally, including its energy performance. So we have a role to play in that space as well.
And of course, all of those spheres are somehow interconnected. So again, the complexity rises even more, because I can imagine as a modern manufacturer, we need to take, for example, care about your building efficiency as well. You can't just focus on the production process when there are these low-hanging fruits with the building.
Yeah, absolutely. I think what we're trying to do is look, in terms of looking at some of our portfolio that we can promote into this space. We make no difference between building energy management and factory energy management. You know, we have tools that we can provide an end user that really covers both of those activities.
Okay, so since we are already talking about manufacturing a little bit, I think that we should stay on this for a while, because, well, obviously most of our audience is somehow related to the manufacturing space.
Right.
So maybe we can go into details how, what kind of solutions, maybe specific solutions, are helping manufacturers to solve their problems with well, the challenges that you described. So not only saving, because of course energy saving is a very important topic, but then there is this resilience and net zero regulations and so on. So if you could go into details of that.
Yeah, well, I think we can help manufacturers in three ways. Those are providing solutions that provide a degree of energy efficiency. We have solutions which support asset energy management in the manufacturing space, so better management of their manufacturing assets. And finally, we have solutions which can provide or support resilience, so battery energy storage solutions, microgrid management, and energy trading software. So if we take each of those in turn, I think I'll start with energy efficiency, because one of the things we did find from the survey work that we did was where a manufacturer will often start their net zero journey is to actually implement and use more energy efficient equipment. You know, that certainly came out of the statistics that we saw. So what do we mean by energy efficiency, and what are the products that we as Mitsubishi Electric can play with to support a manufacturer in that space? And I think really there's two parts of our portfolio that we're going to talk about. The first of which is our inverters and our drives used for control of motors. So certainly that is somewhere where a manufacturer can make savings, and we've got some great case studies available to us which demonstrate the move away from using direct online motors to using inverters for inverter control of motors to provide energy savings on a manufacturing process. It's very easy to provide statistics around a return on investment when implementing drive solutions. So that, for me, I think is probably number one of our portfolio as to where a product can be used to provide a degree of energy efficiency.
I don't have the number in mind, but I've read statistics as well that they say that the major contributor to production systems energy usage are the drives.
Yeah.
So the motors
Yep.
Like if you consider a typical plant, manufacturing plant, there are hundreds, if not thousands, of motors, and they are usually the main contributor to the usage of the energy. So definitely, like starting with proper inverters, which they steer the motors, it's definitely the right place to start. But I guess it's not the only one.
No, that's right. Yeah, I mean, of the others, I think we'd look at in that product space, providing energy efficiency is probably the use of servos over pneumatics as part of control of a manufacturing process. That it's not quite so easy to quantify as a drive, but it certainly does also lead to a degree of energy efficiency as well. And the third one, and it's not something where we necessarily play as Mitsubishi Electric, but the third one that is great for a manufacturer to start that net zero journey is lighting and management of lighting. The moving towards LED lighting in the factory space over traditional lighting, that has certainly been key as part of those first baby footsteps towards the journey to net zero. So that's the energy efficiency a bit. The second one is asset energy management. When by asset, I mean manufacturing assets in this case. You know, we have a great range of solutions in that space around our modular PLC and compact PLC offering, as providing a mechanism for data gathering off a manufacturing asset, which we can then aggregate that data and visualize it through either our HMIs or through our Iconic Suite software to give insight into the energy consumption of that piece of equipment. And what do we want to do, really? We want to be able to turn it off when it's not being used. And it's as simple as that. You know, it might sound crazy, but you'll be surprised at how many manufacturing process you will see where they're not actually manufacturing anything, but that piece of equipment is switched on and is running. And that is often a place where you can start to make savings. Switch it off when you're not using it. Yeah. So that's the energy management, asset energy management piece, using our PLC products and our visualization tools, including Iconic Suite. The final piece, which is around how we can help a manufacturer around resilience and help them with their energy mix on site. And by energy mix, I mean the carbon intensity of their energy mix. So moving them towards greener energy. So that might be them using their own local resources or just consuming electrical energy off the grid when the carbon intensity is lower. And as long as you've got some degree of battery storage, that is possible, as long as there's some flexibility in your manufacturing process. And again, that is a place where Mitsubishi Electric can play in the provision of battery storage solutions on site, and also in the provision of load balancing solutions around the energy mix management, understanding the carbon intensity from your main grid. Those figures are published, certainly they are in the UK, in real time. So we know within any given hour what the likely carbon content is of your energy mix that you might consume as part of your manufacturing process. So that's the third piece where I think we sit there, is around energy management from a grid perspective on site. And as such, you know, there's parts of our portfolio from a company called Microgrids Solutions, which is a Mitsubishi Electric company that offers software exactly to do that, sort of virtual power plant management, and also energy trading as well back to the main grid.
And so when we talk about asset management, it's clear that and that's across different functions of the manufacturing facility. But generally speaking, transparency is what matters. And what you're describing here is making also the carbon usage very transparent.
Yes.
And I think that a lot of companies have struggles with exactly that point, right?
Yeah, absolutely. And that's something that we've been able to do through our Iconic software. Is obviously in the UK, the government publish an API which gives you real-time information of the energy mix regionally across the UK at any point in any hour of the day. We can surface that through our Iconic Suite therefore relate it to your production needs. And so you can start to manage production against what is a forecast of the carbon intensity of your energy from the main grid. And if you have some battery storage, obviously you could then, if you like, reduce your consumption from main grid to use your stored energy if you know that the carbon content of the energy from the main grid is going to be high, and vice versa. If the carbon content's low, perhaps you could store some of that energy for use when it will be higher at a later point in time. So better control over that carbon intensity of your own consumption of energy, I think, is going to be key for us as manufacturers start to move towards net zero and actually reducing carbon in their manufacturing processes rather than just offsetting it. You know, we talk about carbon neutrality, and I think personally, you know, I think it's a bit of a cop-out that actually what we do is we'll talk about carbon offsetting. So we won't look at the carbon content of our manufacturing process, but what we will do is go and plant a bunch of trees over in some other area, you know, local geography. That's yes, that works from the perspective of reporting on carbon neutrality, but is it really good for use of what we should be doing? No, I think we should be reducing carbon in our supply chains.
Yeah, and you just described the way how to do it, right? Because the first thing is to understand where you are,
yeah,
and then assuming that you are capable of creating this kind of microgrid system,
yeah,
then you know how to do it, right? So you see the monitoring data, right? You know where you are, and then by the energy that was stored and so on, you can somehow offset this a little bit.
Yeah.
So for sure, it is a way forward, especially for those energy-intense factories. But honestly speaking, all that you described sounds a little bit complex to do. So the question is how we can somehow start this journey, how we can, if I would be a manufacturer, right? How I can start today my journey towards this kind of advanced systems where at the end, I am able to actually reduce my carbon footprint.
Right. Okay. I think, to be honest, so we're talking again about, in terms of these energy solutions, we are really effectively talking about digitalization. Mm-hmm. Okay. And I think there are two key barriers to digitalization projects being adopted and being successful. And I think those two barriers, and these are shown by some of the statistics that we have, these two barriers are, one, cybersecurity. We're not going to address that today in this topic, but it's certainly an issue. And the other one is scale of it. It's biting off more than you actually intend to in terms of where to start in terms of this digitalization journey. And I think Mitsubishi Electric is certainly aware of that. Mm-hmm. And actually, I think we've come up with a great methodology to support manufacturing to actually address that very point. Where do I start? And that concept we brand as SMKL, which stands for Smart Manufacturing Kaizen Level. Go and look at our website. On our global website, you'll find a lot of detail about this topic there. But SMKL, actually, what it addresses is this concept of have a vision, know where you want to get to, but start small. Look for areas where you have pain. So in this instance, perhaps some assets which are high energy consuming. So you've understood a pain point, and you look to address that through automation, through sort of data management and getting insights out of the process to provide a methodology for reducing energy in this case. But start small, find a quick point where you can get a return on investment. And so that SMKL model is broken down into a two-dimensional array. So this is how we visualize it. On the y-axis, we have something we call the maturity level, which is really the degree of how you use data in the process. And then on the x-axis, we map management level, which is really the scale of the operation. Remember what I said about starting small? So we probably want to start, if we visualize this sort of XY array, we want to start bottom left corner. And then in terms of the maturity level, what we're talking about there is just collecting data. Being able to then, from that point of collecting data, be able to visualize it. From that point of being able to visualize it, be able to analyze it. From the point of analyzing it, then being able to optimize. So we go through that whole journey, but we could just start with the data management piece to begin with. Scaling it, we can start at a single asset, move across multiple assets, multiple lines, whole plant, multiple plants. So again, our vision might be to go, if you think of the XY array again, to the top right, where we are going across, and we're going across multiple assets and we're actually optimizing energy. And what we've done is actually map our energy management solutions against that SMKL model. So we have small solutions for where you're starting small, but you want to dream big. They're all modular, they're all scalable. So we start small, and we use our compact PLC to drive data collection. We can then use our HMI tools through our GOTs or through Iconic Suite SCADA to actually visualize. We can then optimize. We can then optimize and provide insights into the data to look for energy management potential and reducing energy consumption. And then we can actually analyze over the top of that as well, using some of our AI tools in order to be able to predict energy usage and to reduce it with time.
And I think a key takeaway about SMKL is what you mentioned, is that you have different strategies depending on where you are. Yeah?
Yes.
So you don't use the same tools to get to the last stage, for example.
You need to map where you are now and where you want to get to. You may have already embarked upon this journey, so it's understanding where you are now. And obviously, if you haven't started, you're right in that. If you remember my XY graph again, you're right in the bottom left of that journey.
Yeah, I agree. This tool is very, very simple. But then again, it allows you to visualize where you stand, and it makes your life much easier.
It's simple, but it's powerful. I think often the best tools are exactly that.
And SMKL is well tested in manufacturing, right?
Yeah.
So it is not something that just sits there as a kind of like a concept. It's SMKL. It is a framework that was tested in various types of manufacturing topics. So not only energy management, which clearly is very important, but on my last conversation, we talked about implementing this in the water treatment plants, right?
Right.
So it is very versatile in terms of usage.
We certainly use it in our discussions with our customers as helping them in that consultative process of delivering these sort of solutions into our customers. We use it to help visualize where they are now, where they want to get to, and that we encourage them to make use of the tool as well. If we've got time a little bit later, I'm sure we'll talk about this when we start to discuss, I think, AI, which is probably where we're going to go on to at some point.
Yeah, AI is definitely the next topic I wanted to discuss, because next to carbon neutrality, net zero, and so on, artificial intelligence is another buzzword that is these days is, let's say, you can see it everywhere. But for sure there is a reason for that. And we know as a fact that artificial intelligence is already transforming, for example, production processes. So maybe we can also discuss the influence of AI on the energy management topic. So I'm sure you have some experience already. So maybe we can outline the basics, but also maybe going through a specific example.
Okay, well, remember what we said about SMKL and dream big, start small. Let's look at the dream big bit to begin with. I think what I'd like to see, and I think AI will definitely have a role to play in this, is that when we're starting to look at our manufacturers, and we're looking at production, and we're looking at production scheduling, that we start to manage, and this is what I was alluding to earlier with carbon intensity, that we start to manage not only our production schedule against demand for product, but also against the energy mix that we have coming into site that we're going to consume as part of the production process, so that we ensure that we're producing product at the lowest carbon content possible. And I think AI has a role to play in developing algorithms to achieve that. Not happened yet, not certainly in any instance that I've seen, but that for me is definitely the dream big piece as to where I think AI can play a role. So, and perhaps even depending on the process, including the weather into that mix, because that in some cases does have an impact on production. And so we have to use that in terms of the equation of how much energy that we're consuming at any given point in time. So the AI definitely has a role to play there, but we have to start small. And I think that's, we have some examples of where we've started to use our own AI tools. So we have an AI tool as Mitsubishi Electric, which we brand as MALAB. And I think you've probably had some previous experience on some of these podcasts talking about MALAB. But I won't go into details on it here, but we've certainly looked at some opportunity using the SMKL model, where we start small, to harvest data, and then to utilize that data through the AI engine to provide some insight into the performance of different pieces of equipment. And I'll give you one example of that. We've been working with a customer, that's a food manufacturer, and obviously as part of their energy mix on site, they make use of steam boilers. Those steam boilers in this instance are actually LPG fueled. LPG fuel is expensive. They want to understand how they can improve the efficiency of those steam boilers in operation. So we applied then the SMKL model to that idea. Our goal in this instance was to understand how we could improve the efficiency of the boiler to reduce the amount of LPG spend that particular customer had. So what did we do? Remember that SMKL model and what I talked about, the maturity level. So first up, data, collecting data. In this instance, on this particular steam boiler, they weren't collecting the data they needed to understand in the first instance how that boiler was operating and how efficient it was. So the boiler needed to be re-instrumented to provide all the variables that they needed to better understand how the boiler was operating. Once we did that, once you get that in place, we then want some form of passive data collection over the boiler to collect all those variables, so that we can then start to understand what of that. Remember, this is all part of root cause analysis, and I think that's where AI plays a great role, as a tool to help root cause analysis in the manufacturing space. Is that what we can do is then use a PLC, like a compact PLC, to passively collect data. So, and then visualize it. So we're moving up that maturity level. So we've gone from collect to visualize. So across that boiler now, it's been re-instrumented. We have a PLC that's collecting data. We can visualize that data associated with the operation of the boiler. What do we do next? Well, we start to collect that data historically over time. Having done that, we then effectively look to move up the maturity level again. So we've gone data collection, we've gone visualize, we're now looking at analyze. What do we do with all this historical data? We run it through our MALAB tool, and we look for correlation. We look to understand what of all those variables that we have collected data on, process parameters, actually impact boiler performance. Once we understand where we have the correlation, we can develop then, or rather the MALAB tool can start to develop an algorithm that will support the prediction of the likelihood of that boiler starting to drop in performance over time, and then warn the operator that it's going to drop in performance so that they can make some manual changes. So we've stepped up that level, and then the final one is analyze. So we can actually close that loop. Haven't done it yet. That is something I've seen manufacturers are concerned to do. So they'll use AI to present and provide insight, and then use an operator to make a change. Obviously, what we can do with the MALAB, our MALAB tool, is to close the loop and automatically apply changes. And hopefully that will start to happen soon.
And I will get back to that, but actually I wanted to praise the example that you just gave, because it is a perfect, let's say, use case where you can start from really the beginning and then implementing whether sensors or data collection equipment, even to understand your stuff, your product. And this is a great example, but if you are a manufacturer that is a bit more mature, I can imagine a company that already collects a lot of data on the site. And basically this maturity doesn't change the fact that you can still implement MALAB or artificial intelligence also on this stage, on the later stage, because all this data that you already have somewhere can be used for the AI training, right?
Absolutely right, yeah. In the instance of the steam boiler I referred to, there was no data, so we were starting from scratch. But in many instances, in fact, one of the, if you remember, if you go back to the early noughties, in the early 2000s, it was, you know, the discussions were all around big data and the harvesting of big data. So many manufacturers collect all this data, but they don't know what to do with it. It's just a lot of data. And I think what tools like MALAB do is start to create insight and meaningful information from that data. Yeah.
I think it's important to mention that, because that if you are even more mature, maybe you are even more suited for AI tools, because I think that majority of manufacturing companies, they already collect some information, but now they have ways how they can actually easily start making insights out of this data.
Absolutely right. Absolutely right.
Yeah. But you mentioned another topic that it's very, very interesting, and this is what happens at the end, and this, let's say, decision taking at the end, right? It is, from your experience, right? My understanding is that AI can already take these decisions almost by itself, without the influence of people who are on daily basis, you know, working on the specific equipment. So according to your experience, does it already happen that AI is taking decisions?
That's the point I was alluding to over where we were, our journey with this steam boiler, is I think there is definitely a reticence to completely close the loop. So a manufacturer may use AI to predict and provide a degree of predictive analytics and give therefore an operator the knowledge or awareness that a change needs to be made. That change is then made by the operator, maybe interacting with the control system for the asset, but it's certainly operator driven. Whereas what you can do, and I think the journey will proceed in this direction, what you can do is closed loop control. So the AI can manage the algorithms around the data to understand when a change is needed, and then to actually impact and create that change itself. That will come. Have I seen any instances of it happening yet? No, not personally, but it will come. Yeah.
But I think the reason is that I think that we still prefer to have humans, let's say, taking this final decision.
Yes, I think so. Yeah,
okay.
I think so.
David, it was a pleasure as always. This was a very good conversation, quite a long one comparing to the others, but maybe I would give you a chance to summarize this. So if you would have to decide what is this one key takeaway from this conversation, what is it?
Well, yeah, for me, I'm going to say there are two things, to be honest.
That's fine.
One, we're all together on this journey towards net zero. Yeah, we might be getting tired about hearing about it, but I think our manufacturers need to play a better piece in this on this journey. You know, we as Mitsubishi Electric have solutions that can help them reduce carbon, which by and by actually improves. Likely it reduces energy cost as well, because if you're reducing carbon, you're probably going to be reducing energy cost. And as such, we have the tools to do that. I think the role of AI is starting to be seen and will just grow with time. And I think the other thing to think about is digitalization and applying that methodology. Dream big, but start small. Look for your pain point and really focus in on where you can get a quick return on investment. You know, the cliched low-hanging fruit, but it often is there.
Yeah.
It's often there. So just use that SMKL model and methodology to start to look at that.
And I think starting small is dreaming big, and starting small is a nice wording to stop the conversation.
Yes.
So thanks a lot, and I would use your time still to answer a couple of questions,
Yes, no problem.
as we always do. Starting from the top, and I think that you partially answered that one, but maybe we can still go into details. The question is, can we use AI at any point of this scaling up procedure? So maybe rephrasing this a little bit, taking the SMKL methodology, would you apply AI on every stage, or would you focus on like specific maturity levels?
I personally, if we look at the scaling element of SMKL, so as we move across individual assets towards a line or a collection of assets to a plant to multiple plants, I think you can apply AI across all of those. And often actually applying AI to at the low level around perhaps a single asset is the place to start. If that is where that you have identified that there is a pain point that can be addressed through the use of AI, start there. The tool is such that you could apply to this sort of small solution as well as to a solution which covers multiple lines and plants across a series of manufacturing sites.
Yeah. And I think important feature of MyLab is that it is not like a big platform for data analytics. It's a tool that can be used with any size of the data, right? So even if you have a small set of information from your factory, you can still use
you can
this
start to look for
standalone
correlation.
software, right?
Absolutely right. Yeah.
Mm-hmm. Okay. The next one is the question about the return on investment, and so very practical question. The average return on investment for the cases that you've been working on. Do you have any numbers that you could share from your experience?
Well, we've been looking at this. Let's go back to the steam boiler so that we know in this case what the LPG spend is. Okay, and through that we understand where we think we can get to improving the efficiency of the boiler. Mm-hmm. We therefore know how much LPG we can save. And we can then turn that into an ROI calculation. And on that specific example, you're probably looking at somewhere around 6 months as a return on investment, which is the kind of level you would need to get from a food manufacturer in the UK to consider investment.
Right. And you mentioned about the subsidies to the electricity costs and so on. We have something similar here in Poland, and I think that it is ending soon. So that means that the costs related to any type of energy, but definitely electrical energy, are going to rise very quickly.
Yeah.
Right. So I think the ROI will get better, much better.
Yeah. As electrical energy starts. Well, this all comes back to what I was saying about electrical energy pricing security. You know, because we've had this shock to our electrical energy pricing over the past 2 years. Yes, it is coming down, but there is concern over security and the likelihood that it will rise again over time. So being able to mitigate against that by better consumption of energy, lower consumption of energy, and maybe even introducing your own renewables into your energy mix, that certainly in the UK is a trend and a growing trend, where we, as part of our survey work that we did, when we talked about pricing security and models that a manufacturer may look to improve, mitigate against the risk of cost rises, and also looking at how to provide better resilience across their processes, is creation of use of their own renewable resources at site, electrical energy resources, be that PV or wind as being the two main renewable energy resources that they might utilise. 50% of the manufacturers we surveyed said that is what they were going to invest in. So effectively, generation of electrical energy at site with a degree of storage to mitigate against the stability issues of it, and also the management of that local grid themselves, which also enables them to trade and produce another revenue stream for the business if they want to. Yeah.
And it makes you immune a little bit to the costs that are the market costs.
It mitigates against that's price security issue.
I don't think we have time to discuss this today. Maybe at some point in future, but we have plenty of use cases from Japan, right? Because all the resources in Japan are extremely expensive. And this has been driving this need for energy efficiency in Japanese factories, right? Yeah, so there is a lot of also numbers, like specific ROI numbers from the experience of Japanese factories. But okay, maybe we'll discuss next time.
We have some of our own factories, don't we,
exactly,
in terms of the metrics that we can explore there. Yeah.
Perfect. Next one. I like that question, but I'm not sure how to answer it. What or who do you think will drive the transition to net zero in manufacturing?
Oh wow! Okay, right. I think there are many players in that space that will drive that net zero in manufacturing. I think government legislation. I think there is a role to play there. And I think there is a move, certainly I can only talk about the UK space here, but there is a move towards making it less, let's use the word de-incentivizing carbon offsetting to actually looking at carbon reduction. So I think there'll be more emphasis on that within the manufacturing space. We have schemes in the UK called ESOS and ISO 50001 as a scheme to help manufacturers in terms of their energy management. So I think legislation has a role to play. They themselves have a role to play in terms of being a part of society and our drive towards carbon neutrality. They need to implement these systems. And I think one of the things that the pricing shock has done is actually stimulated that carbon reduction, net zero journey, really driven actually by a need to reduce cost. Right. Yeah. So I think that certainly happened. I think it's on them to do that.
Yeah. My first thought was also governments that already create incentives to go in this direction, and it might create some disturbance.
Carbon credits and everything like that. Those processes are there.
And they already started. That's for sure. Yeah. But then again, I was also thinking that definitely various technologies are also the drivers. So technology seems to always shape all these major changes in a way that sometimes we don't really can't predict. And I think that AI is one of those tools.
Well, yeah, I think technology is the disruptor in the energy market, and that's what we spoke about earlier. And I think how that's manifested itself is actually driving this idea of moving away from our traditional power grid to smart grids. That's, you know, and the smart grid in the case of a manufacturer could just be effectively their own environment, where they're managing their own energy from a production perspective, producing it to a degree, storing it, consuming it, and trading it. Yeah, they're able to do all of that, and that's done through the technologies that are now available, which with time will start to be AI based as well. They already are in some instances. So many of the energy trading algorithms that you'll see available will have an AI content to them to support, obviously reaction to the markets, energy pricing, and then so therefore looking for opportunity using AI to trade at an optimal price. Mm-hmm. Yeah, so that's certainly happening.
Yeah, I think that it's not a surprise that AI is definitely one of those disruptors. All right. I think there is one more about can we get the presentation or some of this information that we shared during your speech? Yes, we will do so. We just need to get into contact somehow. So maybe we will find your email address and then we will send the materials, if you agree, to your email.
What I would say there is we've just launched a new energy website as Mitsubishi Electric in Europe. Yeah, and much of this material that I've been discussing today is available on that website, including some of the case studies and some of the video collateral. Also discussion on SMKL. So, please go and have a look there. I'm sure you'll find what you're looking for.
Yeah, maybe someone can post this website address to the chat. I agree that it's quite interesting already. Perfect. David, it's been a pleasure.
It certainly has. I've enjoyed it. Thank you for inviting me, Piotr. Yeah.
Thank you all.
Thanks very much.
And,
thank you.
We'll stay in touch.
Thank you.